I'm blue. So let me spotlight me because I'm. All right. And then I'll do this so I can still see the two people that have their cameras on. Thank you so much. All right, so let's see. So for example, how do I know that this is possibly factorable?
Camera needs to come up a little bit.
Oh, sorry. Hold on. I'm trying to pick one that works. All right. How do I know that this is possibly factorable?
Because 4 goes into 8?
More than that, because 4 is exactly
Twice?
half.
Or half, yeah.
Yeah.
So
because
backwards in my brain.
when I try to factor this, I cut this sucker in half. And then the middle term is going to be made of x to the 4th. So if that was any other number or that was any other, it wouldn't work. So then I can see that this will work. Yeah. And then, of course, this doesn't do shit. But anyway, that's an example of the powers telling me that it's possible. The one you got, let me see. Let me see if it's going to work the way I think it is. Yeah, cool. Ooh, that one's nice. I like that one a lot. I would. So I don't know. It's hard. Screw it. I'll go ahead and do this problem. Why not? I'll do the first step, and then I'll point out what to do from here. So again, I know this is possibly factorable because it's 3 terms, and that is half of that. Because the first thing I do is cut the damn thing in half. So of course that's got to be half of that, or else it's never going to match up. And of course, what goes here and here?
Negative 8 and positive 1.
And then try to help. All right, sorry. Yeah. I don't know what I was doing. And of course, what are each of these?
Perfect cube.
Perfect cubes. Little dude, big dude, little dude, big dude. Yeah. I love that problem. I would. The interesting thing about difference or sum of cubes is you are guaranteed to have 1 real answer and 2 imaginary answers. Because there's a few different reasons why. The most obvious reason why is, can somebody tell me what this looks like? Or let's do this one. What does this look like? My graph, and what does it look like? It looks like something moved somewhere.
It's like a giraffe missing 1 leg, moved up 1.
I like it. Now you're going to make that a useful thing. I'm going to have to tell Corey that he actually has something. Stop it. So it's I don't know why I'm being all specific. I don't care. So it's normally here, and now it's been moved up to here, right? So it's never, I don't care how much I move it up or down, it's never going to have more than 1 real solution, 1 real X-intercept, right? So I'm guaranteed that the little dude will be related to that, and the big dude will have complex answers. Anyway, all right. No idea if that's any interest to anybody, but that's how you factor number 18 in 5-3. All right. Let me see. Any other questions? I think that's all the questions I got chatted to me. Let me see how many people I'm missing. I'm missing 10 people. That's relatively trying to be happy about that somehow. But oh. Anybody? Everybody else okay? When finding zeros and you get one factor, should the next factor fit into the answer? It almost makes sense. I'm not sure I'm following. I don't know what that means. When finding zeros and you get one, so you get like a number that works synthetically, right? You do synthetic division and it works. And what do you mean the next factor? What does that mean? Should the next factor fit into the answer? Maybe. I think I know what you mean. Not 100% certain. I think I remember. Let me see if this is true.
So like if you get a number and like -4 is a factor and then it comes out evenly and say 2 is also a factor, does 2 have to fit in both the original equation and the second one you get after you try -4? I don't know how to explain it.
So I think I know what you mean. And
Okay.
the issue is when you get something that works, blah, 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 and you get something here.
Yeah.
That is a part of the end. That is a part of the end answer no matter what.
Yeah. And then whatever you get after
And then this
that.
works. Say, Nick, this works.
Yeah.
And that's
so-
going to be a part of the answer.
So would the -4 work in that and the original equation?
Of course, yes.
Okay,
It's-
yeah, that's what I was asking.
The same as if I were to reduce 68 and somebody said, all right, I'm going to divide it by 2. And let me see, what's a better, let me give you a better. Let's do, sure, 30. Why not? Let's make it easy, Jeff. 30. And I divide it by 6 and I get 5. And then my friend is like, well, I divided by 5 and I got 6. Well, I don't know if that makes any sense. So of course 6 would have worked in 30, or if you, let me see, I'm trying to make it more fit what you're saying. If I do 60 and I divide by 6, I get 10, and then I divide by 2, I get 5. 2 would have worked in going into 60, right? I mean, that's the
Okay, yeah, that's what I was asking.
yeah, and the thing that's really weird is these are numbers. So the way that numbers work when I factor are the same way that polynomials work when I factor. They just look very different. I mean, if I knew what x was, these are just numbers, right? In fact, that would be interesting. I don't know if you guys have ever seen this before. I'm trying to remember if this works. Let me see real quick. Let me do some work. Look away. I'm trying to remember if I made one that worked earlier. I could just make another one, but I'm kind of stuck on this one for some reason. No. No. Well, yeah. I think so. I think 2 works. Let's see. 1, 2, 2, 4, 3. Almost. Would it be -2? No. Screw it. Maybe it would be -2. -2, -2, -2, 4, 3. Yeah. Okay. Good. All right. I like it. Now, after all that shit, I forgot what I was going to do with this damn thing. Yeah, it's that kind of day, kids. I'm sorry. So if I have this, yeah, that's what I wanted to do. All right. So help me out. I got this to work. Well, how do I set up this? What do I put up here for this guy? Am I sharing? No, I'm not. Good. Keep me honest. What goes up here?
0, -1, -6.
And by the way, I really want to make this point to you guys because I think this is something that you easily miss. Before we talked about synthetic division, is that something you could have factored ever? And related to the discussion we had earlier, that's a 1 and that's a 3. Is that something I could have factored ever before? Oh, come on. Remember we did the one that had an 8, but then the middle had to be 4th power, right?
No, you can't factor that.
There's no way in hell I would have been able to factor this. Now that we got this method, I can factor shit like this. And I just really want somebody out there to go, that's kind of interesting or something, or at least, I mean, it's neat. We're opening doors, and I know a lot of you guys are like, I didn't need those doors to be open, Jeff. I was fine standing outside the door on the other side. But now we're able to do more shit, which makes a ton of, all right, so real quick, if I do this, 1, -2, add, multiply, oh, it's supposed to be +6, what? Make that a +6. I'll get it eventually. Okay. So now what is this? This will be, what does this relate to?
X plus 2.
And of course this is,
X squared minus 2x plus 3.
yeah, so then I get x plus 2, x minus, well, let's see, is this factorable? No. So maybe I should have, anyway, it doesn't. So here's my big thing. All right, that's not factorable because -3, -1 makes -4 not -2. Anyway, what I want you to realize is here's the connection, and this is something that some of you guys probably have seen before. It's not that big of a deal, but what is x? What is x? And I love, is x 7?
It's a variable.
Sure, so what's that mean? X,
It could
let
be
me
any,
try. There you go, beautiful, that's it. It could be anything. So let's pick 3. What if x is 3? Why 3? Because like Jason just said, it could be whatever the shit. And 3, I like the number 3. 3 is better than 18 billion and 7. So let's use 3. What is this number then? If x is 3.
12,
30.
No? Yes.
30.
3 cubed, so 27 minus 3, 24 plus 6, 30.
I missed the cube, sorry.
What are these numbers if x is 3? What's x plus 2 if x is 3?
5 times
5. And then what's x squared minus 2 if x is 3?
6.
6. I love it. Which is kind of funny because it was the 30 thing I had earlier. But isn't 5 times 6 a way to factor 30? So that's the concrete idea behind this very abstract thing we just did. These are numbers. This is a number. This is a way to factor that number. What number? Well, give me an x and I'll see what the shit numbers they are. Has anyone ever seen that before? Some of you guys? I'm seeing it in more textbooks, but it's something I've always done because this is so abstract. And I want to remind people, why is this so hard? It wasn't really that hard, but it's definitely harder than factoring 30 because we're factoring an infinite number of numbers at once. Because x could be anything. So of course this is going to be a little difficult. In that sense, this was easy as shit. What'd you do today? I factored an infinite number of numbers. What did you do? Right? It's like, dude, what the shit? All right, sorry. Okay, maybe. All right, so just in case you've never seen that, that's a very good thing to see related to factoring. It makes it a little more concrete in the background. These are just numbers. They have to act like numbers because they are. Okay. So that's why it related, that question you had related to this situation. It's exactly the same situation. I love it. Okay. Any other specific questions that I can just talk about forever? Or general questions, doesn't have to be specific. If not, I have something I want to do that I'm kind of surprised I haven't gotten a question about. Hopefully I actually, let's see, did I assign this? That would be funny, Jeff, if you didn't get a question because you didn't assign it. You're going to have to deal with me. Today is a rough day, so you're just going to have to deal with me. Oh, somebody got a nifty question. I'll do an easy one just because I don't want to spend too much time on it, so you get the idea. Somebody's asking me to do a synthetic division with an imaginary number. Let me see, 5, 3. Yeah, 43, 45, 46. I did. Good. All right, I like it. So let me do that first, real quick. So something really simple. If this is too simple, too bad. So this has imaginary answers, right? If I do this. So I should be able to divide it by, let's do 2i. You guys understand? I should be able to divide that by 2i. So let me see, what would I put here?
104.
So let's try. Bring the 1 down. 2i times 1 is 2i. Add 2i times 2i is what?
-4.
Good, because it's 4i squared, which is 4 times -1, it's -4. So see how that went in evenly? So then you do get x, what does this one relate to?
X minus 2i.
Yeah, forget the I, it's the same, whatever the hell that is, it's x minus that. And of course this is,
X
plus
plus 2i.
of course, we know that's how that factors, right? So complex is disgusting as all hell if it doesn't actually go in. If it goes in, it's easy. Or let me be careful, relatively easy. I mean, this isn't really a complex number, truly. It's purely imaginary. Can you imagine trying to divide something by this? Put that in the penalty box. That would be a nifty problem, and that sounds like something I'd like to do for like extra credit on something. It'll work. It'll work. If that's an answer to it, it'll work. It'll just be gross and then suddenly nice. All right. So now I have another question. What was the other question? Somebody just asked me. Oh, this is what I wanted to do. Okay, that's right. This is my question. All right. I want to apologize again. It's been a long day. Oh, wait, here I have a question. So before I do my thing, I'll do this one. So 5-4, number 10. And on top of everything, I got like crazy allergies. I love it. Oh yeah. Okay. I love it. I love it. I love it. So here's the problem, and I can almost tell what the mistake might have been. Right? I'm gonna do this one because. Did you have a problem with this, or did you just want to see another one like this for some reason? Person that is chatting to me, or did you have a problem with this one, or will you ever talk to me again? What happened?
Do you plug in zeros for the missing values when you're dividing?
Totally. So I'm not hearing back from the person that asked this problem, so I'm pretty sure I got the right problem. Number 10 and 5-4. So exactly, the 5 goes here, and then what are you gonna put? You're gonna put 1.
It
and
wants
then-
long division for that problem.
Oh, they want long division? Is that
Yeah.
what it is?
Yeah,
Oh, okay, okay.
that's why I was asking.
Yeah, you're right.
Zeros.
So if they want long division, it still works the same way, you're right. So you're gonna put x cubed plus 0x squared plus no x's minus 126. Yeah, yeah, thanks. Sorry, man. Yeah, and then I don't know if the question is remembering how to do long division, or is it something specific? Is it forgetting to do this, or I don't know. Or do you just want to do another long division problem? Is it the long division that you want to review, or is it something specific about this problem? Oh, okay, there you go. All right, done. Right, and then you go x times x squared, blah, blah, blah. And you just do the long division. Can somebody see if I put what here, this would go perfectly? If I didn't have 126, if I had a what there?
125.
125, because then this would be a cube, so if you have an x minus 5, it'd go perfectly. So you should have a remainder of all right.
1.
Some kind of 1. I'm sorry. We all right?
I was gonna say that if they didn't have, the person who messaged you directly didn't have a question about long division, I was gonna ask if you could just go over it, like just do the one that you had written out, which was x minus 5 square root of x cubed plus 0x² plus 0x minus 126 because I've been avoiding doing long division.
All right. Well, I'm not going to do that one because that's in the homework. But so I'll make another one up. And be very careful.
Yeah.
I'm not being picky, but this is not square root. This is just the division. I know it looks like square root, and that sucks. But this is just the division symbol, right? So we'll do like, I don't know. Sure. Okay. So what did I say a minute ago? These variable expressions are numbers. They have to act the same way that numbers do. So back in the day, if I had to do this, how would I figure out what number to start with? Well, I would actually look at 7 into 50 and say that's 7. And then I would do 7 times 71. So, and if you will be honest to yourself, that's exactly, I don't do 71 into 508. Ain't a single damn one of you that does that shit. We all do 7 into 50. And I know it's not a 7. So when I do 7, I go 7 times 71. So what's the first step here? This into that. Same thing, same thing. X times what is x cubed? X times what is x cubed?
X squared.
X squared.
Same way I did 7 times 7 is 49. But now I don't just do x squared times x. I also do x squared times -4. The same way I did 7 times 71, right? X squared times x squared times -4. I didn't really mean it to be that weird. Oh, I guess I sort of did. And then, of course, what do?
Subtract.
Change the signs. I heard that. So those cancel, those cancel. You bring down the 4x. That's where things get interesting. And you bring down the -12. X goes into 4x how many times?
4.
Yes. 4 times x is 4x. 4 times 4 is -4 is -16. Change the signs. Cancel 4. 4 over x minus 4, which is the same thing we would do with whatever the shit the remainder is. I would put it over thingamajig. That was a little bit fast, but all the steps are the same. And of course, just to remind you guys, if you were to do this, you can actually see the important parts happening. And of course, the 4, 0 is the stuff we don't even write over there, to be honest. 4, so there's the 4, and then 4 times 4 is 16, and then -12 plus 16. I mean, so that was the connection between long division and synthetic. Okay. Kind of ignores the extra shit. Why do I keep writing these things? They're going to cancel anyway. Because why do I keep writing the x's? All that matters is the coefficients. All right, I like it. Okay, anything else, guys? All right, now it's my turn. Here we go. Find the roots. Sure. I like it. This is part A. That's easy. That's easy. I already factored it for you. So what are the roots? What's happening? The A value is -1. Oh, if that's the only, I'm not sure what that question is about. Oh, I see what you mean. So what's funny is, all right, we'll do a problem like that next. Let me put a little note for myself. All right. So I'll show you what you can do depending on what the question is. There's a private chat. So what are the X-intercepts? It's another name for roots. What do you get?
3 and -4.
Yeah, 3, 0, and -4, 0. Let me make one change while I'm thinking about it, just so I can make a big deal out of something. Put a little squared there. That doesn't change the roots, does it? It does change my next question. What are the multiplicities? That's like a word like banana. You're never sure if you're done. All right. What are the multiplicities of each of the roots? Does anyone remember what the hell that means?
3, 0 has a multiplicity of 3.
Yes.
And
So it has an odd multiplicity. And of course, this one has a multiplicity of
2.
2, because it shows up twice. So all multiplicity means is how often does that factor show up? How often does that root occur? Even 2. Can somebody tell me what's the degree of this polynomial?
5?
3.
Oh, no.
We said that. Brian said stop. I think that was Brian. Stop. You're right. Don't change it.
Wait, really?
Totally. Yes. Because if you took the highest degree thing from here and the highest degree thing from here, you're going to get a highest degree of x to the 5th with a bunch of other shit. So if I just ask you what's the degree of this, don't multiply that out. You're wasting time. You can see the third power is the biggest out of this, and the second power is the biggest out of this. Put those together, 5th power is the biggest overall. Is that cool? That might not have been what you were thinking, but just, go ahead and own it. It was the right answer.
Damn, I winged that so bad.
That's all right. See, I told you you could have just taken it and walked away. But all right. So the degree is 5th degree. So what's the end behavior going to be? And it's not a negative, is it? So it's just the 5th degree. What's the end behavior? And the quickest way to answer end behavior for me is to draw something about the ends. What is it doing? Is it going up? Is it going? You guys seen that shirt that's got the guy doing all the different functions like he's dancing? No? That's the shirt I got. What would the end behavior be? Where's my, we had this happen earlier. It was the sad thing that happened on a safari when the lion got to the giraffe, right? I mean, odd roots, odd power, odd degree polynomials will always have end behavior that looks cubish. If it was a negative in front, it would have just flipped these as a reflection. We know that. So what would it, sorry.
Just would it be as x approaches infinity, f of x would approach infinity?
Yep.
And then as x approaches negative infinity, f of x approaches negative infinity.
I love it. Kick ass. The funny thing is, I'm not as interested in writing it that way quite yet. But to be honest, if you're going to take calculus, this whole idea of writing x goes to infinity, f of x goes to infinity is good because you're going to see this kind of thing a lot in calculus. But this is the way you can answer this for me because it actually means more to us than this does. We can connect to this more. So what is it going to do in the middle? Weird shit. It's going to be very wobbly because it's got a lot of other terms. All right, so let me try to keep track of the important things because I need to make more space here. So we got end behavior. Looks like this. I like that. We've got even and odd multiplicities there. I like it. Hopefully you guys had that. Oh yeah, I gotta do that later. So what's it mean right here? What's it mean for it to have odd multiplicity? What does a cubic do through its root? It goes through. And what does a parabola do at its root? It
Touches.
turns. So it's going to turn at this root, and it's going to go through at this root. All right, so watch. This is how you graph a polynomial based on the information we have ascertained, right? So now we're going to graph this bad boy. So first off, there's something really important I need to do. What are the intercepts?
3, 0, -4, 0.
But what else? That's the X-intercept, sure.
Oh. And
This is going to be a little bit large.
-432.
Yeah, because it would be, if you make those 0, you get -27 times 16, right? So what do you get? -432?
Yes.
Okay. So what I do to graph this bad boy, I'm going to have to figure out the scale, right? The scale on the x-axis is nice enough. It doesn't look like it go anywhere too freaky. But the scale on the y-axis is going to be something I got to be careful about. I want to capture that. So I can do 1, 2, 3, 4. That's nice. That feels nice. 1, 2, 3, 4. 1, 2, 3, 4. And I can plot my 3, 0, and I can plot my -4, 0. What kind of scale do I want on the y-axis?
$50.
Okay, 50. So see, -50, 100, 150, 200, 250, 300, 350, 400, 450. Okay, whew. So there's my -432. Will be about right there. So now watch how this works. Remember our end behavior? Don't I start down there? So I start down here, and what am I going to do at -4?
Parabola shape.
Parabola shape. I'm going to turn. So I'm going to start down here. I'm going to approach it. I'm going to turn. Then, of course, I got to get down through this bad boy, right? And this is not going to be perfect. In fact, I probably should have made this a little deeper, but too bad. Then it looks like I'm going to turn. What am I going to do at 3? Help!
Go through.
Drive through it.
Okay. So then you can check. Do you have your right end behavior? Check. Do you go through your intercepts? Do you hit them? Yes, I do. You got your white? Yes. Kick ass. And then you throw it in the calculator to check. If you throw it in the calculator first, your graph is going to come out in a way that I can tell you did that because it'll be in your head. I want the graph to be a little gross. I want it to not be. I bet you anything this goes down further than that or something. I don't give a shit. I want to see that you know how to put these on the graph. Then you check it. The more perfect this is, the more I hate it. Because the more evidence that is that you didn't do it. You just copied it, which is bullshit. Okay.
What about a lot of erasing?
That's fine. You always hit that spot where you're like, huh, I better, move to another piece of paper. But yeah, especially when you start erasing to the other side into the next paper. That's a bad sign. Okay. So that actually is related to the problems in, where was it now? I lost my page. 5.3. Does somebody know which ones I'm talking about? 5.3 number. Where are you? There it is. 42 through 47. I assigned a few from that section. And that is the real way to do those. Okay. Now, any questions from all that? So we talked about every piece of this. We talked about all the pieces. We just never did a full problem. All right. So what I like to do, the reason I kind of missed this in a sense is because I'm used to doing this after we talk about synthetic, because would I give you a problem that looks like this to begin with? No. I'd give you a problem that's not factored yet and ask you to factor it, use synthetic, and then I'd ask you all this other shit. Now, the nice thing that I will do is I will tell you, use synthetic division to show that it factors like this or something. I'll give you some kind of a clue, because if you factor completely wrong, then the rest of your problem is completely wrong. Okay. All right, so everybody got what they want from this? All right, So we got to get back into where we left off last time. That was with the horizontal asymptotes. So the first situation we saw was when the top power is less than the bottom power. So an example we did was 1 over x, and another example would be something like x minus 1 over x squared plus 4x minus 7, whatever this should be. Actually make it legible, maybe. Both of these would have a horizontal asymptote, y equals 0, because as x gets bigger, it overpowers the top, it dominates, so it makes the whole thing go to 0. So the second situation would be if the top power is equal to the bottom power. So something like you're not going to do more with this, Jeff. It's okay. All right. I'm trying to make a problem that works all the way, and like I'm only going to do horizontal asymptote. Stop. Does somebody remember what we did to use this fact that 1 over x goes to 0 as x goes to infinity? We did something like that with this. We divided top and bottom by something. You're like, we don't listen to you. Okay, so you divide top and bottom by the highest degree. What's the highest degree you see in there?
X squared.
X squared. So we divide top and bottom by x squared. What do we get? We get x squared divided by x squared is 1. 4x over x squared, one of the x's cancels. 3x squared divided by x squared is 3. One of the x's cancels there. And this poor little dude, no x's cancel. Now what happens to this as x goes to infinity? What does this piece do?
It gets smaller and smaller.
It goes to,
Approaches 0.
and this piece will go to 0, and this piece will go to 0 even faster. And these pieces don't give a shit what x is doing because they're not affected by x. So what is the limit, or what does this approach when x gets really big? It approaches
1/3.
Yeah. So the shortcut, you guys should see the shortcut by now. The shortcut when the degrees are the same is it'll be y equals the ratio of these coefficients, 1 to 3 in this case. Whatever those numbers would have been, that's what I would have been left with. So the shortcut is it's always going to be, the asymptote is going to be y equals the ratio of those coefficients, the highest degree term coefficients. All right. Let me see. Sorry, somebody. I'm sorry. I'm not paying attention to chat, guys. I'm sorry. Let me see. If the a value is negative in a polynomial. Oh, I'm sorry. I forgot to answer that. I deleted my freaking little note. Let me finish this about this, and then we'll look at that. Yeah. Okay. I like that. Somebody else answered that. He's like, maybe he's just not paying attention to this one person. No, I'm sorry. I just didn't. I forgot all that. So if I had last thing on this one, and then I'll answer that question. And then there's a third situation. That's the freakiest situation. Let's do another example of this type. So if I had okay. So what would the horizontal asymptote be?
y equals 1/2.
1/2, kick ass. Don't just go here. I was evil. There's the highest degrees. The coefficients ratio would be 1/2. Kick ass. By the way, I have put a handout up on Canvas that's got an example, but it also has a box that has all 3 situations in it. So it can work as a reference to help you with notes. So let me finally answer this question. There's a third situation that we're going to do in a minute, but I want to go back. There's somebody asked the question a while back. If the first coefficient is negative in a polynomial, I love it. So the quick answer to your question is, of course not. Because I would just factor in negative out. So that's what I meant by it depends on what the question really is. So if this is the problem, everybody watch Jeff try to think ahead. This is going to be painful. Sure, that should work, right? If you do that, okay, good. So this is what you need, right? This is an example of what you're asking. Maybe.
Like if it's like a -5.
Yeah, well, okay, all right, so you want to make it a -5. You want to make my job even a little worse. All right, I was trying to make it so it would work. Let me do this. And you're like, do what, I think that'll, yeah. Sure, it'll go somewhere. All right, whatever. All right, so what is the question related to this? Like, are they asking you to
Like
factor?
to find the rational zeros. Like if
Oh,
you
find the rational zeros. That is even better. So just take a negative out. I think this is your real question, though. I think you're asking, if I do that, will it change the answer I get? Is that the question?
No, I was just asking, like, because you know how you take the last value and then you divide it by the first coefficient, the highest thing. I was asking if the negative would change those values.
All right, now I'm with you. So the possible rational zeros list, would that change?
Yes.
Okay. So I was thinking, would it change the actual answers that you would get? That's not your question. So forget about this for a minute. The possible rational zeros, I really want this to make all the sense in the world. And of course, I like to throw the even. Doesn't give a shit about this at all. How would I construct this? What would go on top? Do you guys remember? How do I construct the possible rational zeros for this?
1, 2, 3, 6.
You missed something. I agree with what you said.
Yeah, and then
Two.
over
You-
1, 2, 4.
No.
Plus or minus. Plus or minus.
That's why I didn't give a shit. Do you see that? It's plus or minus these, right? And then the bottom is going to be 1, 2, 4. Why don't I put a plus or minus or a negative here? Because that covers all the possibilities already, right? So now I understand your question better now. Do you understand the answer?
Yes.
And if you don't, it's okay. I'm not trying to make you
Yes, I understand.
stop asking, but it is because of the fact that the possible rational zeros includes the positives and the negatives. So that's negative or that's negative, it doesn't care. Because it covers both possibilities already. I like it.
So if you were to do synthetic division on that problem, you wouldn't take the negative out, or would you take the negative out?
I would take the negative.
Do you have to
Is it-
take the negative out?
Well, I would take the negative,
Okay.
but it doesn't matter if you don't. I mean, let's try it. Let's leave the negative in. And I know this is one that factors. I just can't remember what the answer is. Shit. It doesn't matter. Let's see. Oh, this is even worse. Oh my God, this is even worse. Because it really should be this if I'm going to make it work. Yeah, okay. But so if I try, let's just try to do 3, right? So then I would put -4 there, -5 there, 6 there, right? Right? I mean, just take the numbers, bring the -4 down, multiply. And I can already see there's no chance in hell. Right? I mean, you guys get my point. I'm not trying to make this sound, I'm not trying to shove this under sweep this under the rug. It's whatever the hell's there, it goes there. So synthetic division does not care if that's a negative or a positive or whatever it is you put it.
Great. Thank you.
But if my point was to factor this, I would very often take a negative out so I don't have to worry about it. It doesn't change anything though, to be honest. It doesn't even make it that much easier. Anyway, it doesn't care. Okay, I think I made it. So, oh shit. So this one was 1/2. Oh yeah, so now we got to talk about the third situation. And then I want to see if we have enough time. I keep talking about what the horizontal asymptotes are and all that, but we need to see what does it look like when I graph it by hand, right? So we got to get there, but let me talk about this third situation. So the last thing I have to worry about is when the top power is greater than the bottom power. So for example, so you are so going to love this. So on one level, it seems this should be the easiest, because can somebody just tell me what happens when X gets big?
Top gets bigger faster.
And so the whole thing should go to?
Infinity.
So there's no ceiling, Jeff. There's no ceiling. So what do you keep talking about? This is such the hardest one. You're crazy. We knew that already. Well, here's the problem. It goes to infinity in a very prescribed way. So it isn't where the ceiling is, it's how does it go to infinity. So you're going to love this. You have to long divide this bad boy. I want you to see why. Oh, 0 squared. So just go with me. So x, I'm just going to do this real quick. X cubed minus x. Change the signs. I get 3x. And then see how that's less than that? So I know I'm done. Whenever that power is less than that power, that cannot go into that, so I'm done. Now tell me this. Look at me. As x goes to infinity, what does this do? The top power is?
It gets closer to 0.
Decreasing.
Bigger
Top
on the
power is
bottom.
lower than the bottom. The whole thing goes to 0. So what does the function approach when x goes to infinity? It approaches y equals x. And real quick, I want to show you what that means. I want to show you what that means. Shut up. So, let me pull up my TI. Where are you at, TI? There you are. And let it boot up. It takes a while. Poor little guy. Poor little guy. There he is. And let's throw this bad boy in here. Shit, what was it? It was x cubed plus 2x. Okay. By the way, can somebody very quickly tell me what the vertical asymptotes are? I guess that's a no.
Can't really see the board behind you.
Sorry. Oh yeah, I'm sharing. It's an x squared minus 1 on the bottom.
Would it be 1 and -1?
Yes. So at x equal 1 and x equal -1. So when I graph this, we're going to see 2 vertical asymptote situations. Yeah, because basically, although that one, of course, would be strange because there wouldn't be any vertical asymptotes. There would be a circle, an open circle at 0. Now, if you mean like x to the 4th and x squared with other shit, then it would be really neat because then it would have to approach a parabola. It would go to infinity on both sides following a parabola. I don't know if you guys see the chat question. All right, so let's try to graph this sucker. Let me hit zoom 6 just to start off. Yeah, look at that. So much going on. Now let me graph in here a different. Let me actually do something a little different. Let me I always forget how much this go. I think this is going to be too big of a step. But zoom. If I zoom out, all right, this still maintains everything for the most part. Shit, it's a little bit too zoomed out. Jeff, just nothing's going to work perfect. It's all right. Let me just cut this in half. All right. I don't want to lose sight. So here's the -1. You can see there's a wall here, -1, and there's a wall at 1. Right? So cool. And then if I plot a second one, and I love that this dude is colorful. If I plot y equals x, which is my horizontal asymptote, well, it's not a horizontal asymptote, it's called a slant asymptote, which makes sense because it's not horizontal, it's slanted. And sometimes it's called an oblique. Look at that. Isn't that acting as an asymptote? It goes to infinity, but in a prescribed manner. I mean, I'm sorry. I think that's the coolest shit ever.
So I have a question.
Yes.
So if we were to graph this, you would want us to show the asymptote, like with the dotted line, and then write the.
Yes.
Okay.
Yeah, so ours would have a dotted line right here and a dotted line there, and this red line would be dotted. Exactly. So when you put the walls in, you actually create these regions. So we're going to do that. We'll see if I have enough time tonight, because I want to show you one more thing. Since Bahaz asked that question, if I change this to a 4th power, and let me put in here, so this should be basically x squared. I don't know. It's probably, let me see if I can do this real quick. X squared. Yeah, it should be x squared, right? Yeah, screw it. I'm not even going to try. Let's see if that works. So if I graph this now, sorry, this is kind of funny. Let me cut down on the x. Let's zoom in a little bit on the x so we can kind of see better what's happening. Look at that. So it's approaching, it's going to infinity back here and over here, but it's doing so by approaching this red line, which is the asymptote. So this is something I don't think anybody here really knew before, is you can have these curved asymptotes. So that was a good question, Bahas. I like that. So of course you can have any degree of asymptote. It just requires a certain difference in the degree in your function on the top and bottom. Funkadelic. And you can still see the vertical asymptote here and the vertical asymptote there, right? I like that. I like that problem. Kick ass. All right, so let's try to do this. Let's try to do a relatively straightforward example, graphing using asymptotes, and then we'll call it a night. So let's see. Can you make a relatively straightforward problem? We will find out. Yeah, let's just do this. I like it. Sure. Yeah, that's fine. I like it. So very, very quickly over here, what's the X-intercept? What's the Y-intercept? Let's just do that over there. I don't need that much room. Y-intercept is easy, right? You make X go to 0, so then it's 3. What's the X-intercept? This is kind of nifty. I didn't do this on purpose, but oh well.
Also 3.
Also 3, because the top's got to be 0 to make the whole thing 0, and 3 makes the top 0. Good guess. What are the vertical asymptotes?
X equals 1.
And
1.
like I said, factor that, you can see plus or minus 1, kick ass. What is the horizontal asymptote?
Wouldn't it just be y equals 1?
Nope.
Or wait, no, never mind.
What
Sorry.
situation are we in? What situation? We have a top degree that is less than the bottom. When the bottom degree is bigger, it overwhelms the whole thing and it dampens it. I like to think of it as a dampen. As x gets bigger, it dampens it. So it
So it's
goes
just
to
0, right?
like. So when you're about to graph this thing, real quick, what's the multiplicity on the x-intercept? This is kind of silly, huh?
1.
1. So it's gonna go through or turn?
Go through.
Go through. Okay. So I'm gonna go to graph this. Okay. So let's see what kind of regions I've got happening. So yeah, so I can make a nice scale on my x. I don't have some freaky ass x-intercept at 17 or something. All right. So I've got my vertical asymptotes at 1, -1. I got a horizontal asymptote at y equals 0. And notice something. I've made this point before, but I haven't come back to it. Do we have a point that sits on an asymptote?
No.
Yes, we do.
3, 0.
Yeah. Which is fine, because a horizontal asymptote is all about what happens when x gets really big. And is x equal 3 big? No. Here's the funny thing, you ready? Is x equal 18 trillion to the trillionth power big? No. That is tiny. That is nothing. That is peanuts. Because I can raise that to the trillionth power, which is still small, because I can raise that to the trillionth power. It was just still small. So horizontal asymptotes. Here's a really, really funny thing. You ready? I could have a horizontal asymptote like right here, and my function could do this. So this is what's called dampened oscillation. So as long as it's getting close to it, it doesn't matter if it goes through it an infinite number of times, which this one will. It just has to eventually get arbitrarily close to it. That's all that needs to happen. The vertical one is a true wall, because that is, the domain does not include this, so that there's no way to go through that bad boy. It's just off limits. Horizontal is like, could you get closer of it? You know, could you? So it's a less strict thing, and this guy's like, no. Okay. So the next thing I want to do, you guys see how this breaks it up? Do you see how there's a region here? There's a region here, right? There's a region here, and there's a region here. And do you notice how either back here it could be this, or it could be that, right? In here, what do I know about it in here? What's interesting in here? Why can't it be up here and then eventually down here also, for example, on this side? Why can't it go here and then eventually it's over here? You know why. You know why. Because there's no X-intercepts. That's the only way it could possibly go from here to the other side, right? So that's why it's got to be either here, like going up against that wall and going up against that one, or down here. So how would I determine that in this region? I would just pick a number. Let's put -2 in. What do you get when you put a -2 in? Looks like -5 over 4 minus 1. Is that all right, you guys?
Yep.
So that's about, so -2 is about -5/3. Now and before I plot that, so in here, what the shit's gonna happen in here? Could it look like a cubic? You gotta know that answer.
No,
Hell no, because there's no,
no X-Intercept there,
it's gonna look more what?
like a parabola.
More like a parabola. It's gonna be like here or down there. So again, I can just plug a 0, and of course, my y-intercept stays minus. So I know that f of 0 is 3. And then over here, what are the two things it could do here? I know it's going to go through here. So couldn't it go through and then back up to approach this? Or it can go through and then back down to approach this. It could do one of those two things. So again, I can just pick like 2 when I put a 2 in. So do you see how I have 1, 2, 3 regions, and I have 3 points that I'm checking to see where they are in each region. So f of 2 is -1 over 3. Right? So -1/3. So now I can make a scale here finally. I don't see how my outputs are not crazy. So I can make a nice normal looking scale. 1, 2, 3, 1, 2. Is that, yeah, it looks roughly right. So there's my y-intercept. -2 went to -5/3, a little bit past -1. And 2 went to -1/3, which is about right there. So now I can fill in this guy. I know it looks roughly like this. This guy, well, this is a little bit weird. I know it doesn't look like that, right? So it's got to look like this. That's the only thing it can really do. It cannot go down because there's no way it would come back up. All right, and then this guy is going to do this kind of thing, and he's got to do what here?
It's got to go through it.
Got to go through. So this is going to be kind of a little bit weird. It's probably going to do something like that. I know it can't go back through because there's no more intercepts, right? I did that a little fast. We're going to do more of those. I just wanted to get one in your head. And let's very quickly check this on the calculator. Let me see. Like I said, I know that was a little bit quick, and I don't seem to be apologizing, so. Too damn bad was x² minus 1. All right, let me share this. So let me see, let me do zoom 6 just to get a normal. Yeah, what's our scale? Yeah, this will be almost the same scale. Now look over here, this is interesting. Do you see, I don't know if you guys saw, but the slope of it here, I could not have gone like shot through there. So see how it kind of matches up here? It so barely goes through, it doesn't look like it does. So what I can do you agree that basically is the same shape on the calculator? Yeah. So let me just do one thing, my favorite thing, a little zoom box, dude. Yeah, let's just zoom in on this axis here and get a better feel for how this thing looks going through. Well, that's like really zoom, Jeff. So, all right. Bam. Look, there you go. Yeah. But again, I want this to be not perfect. And then you check it on the calculator and you don't change a damn thing on here unless it's so far off, and then you go redo your work. Right? I mean, okay, that's the right way to do that kind of thing. All right, I think that's plenty. I have a feeling that is plenty for today. So if you have any further questions, let me know and hang out. Otherwise, you are free to go.
I have a question.
What you
I
got?
have a question.
Yes.
Do you do office hours Fridays?
No. Most Fridays, they know that. So here's the thing. A lot of people don't work Fridays, and it's not because we're lazy. It's because every damn meeting is on Fridays. It's crazy.
Oh, okay.
It's also when I schedule like doctor's visits and all this other stuff. So it's not easy to have a regular office hours on Friday.
Okay.
Yeah.
All right then. Yeah, because I have some questions, but like sometimes like it's hard for me since I work, so it's like hard for me to be able to hop on your hours. But I'll try to skip. I'll try to skip a day. I'll try to skip a day at work. So
No. If you like anytime, if you shoot me some possibilities for other times, I can tell you what works for me. So each Friday is different. If you say this Friday, can you do this or this, and I can say, yeah, I can do that one, or I can't do any of those, right? So just shoot me an email and say, could you meet for any of these times?
oh, okay. All righty, bet. Sounds good.
Sure.
Thank you, Professor. Have a good night.
You too. Is everybody else all right out there? If you're actually here.
I don't know. I had one question about what we just did with the graphing, because you had said with the I don't know, the one thing I feel like I kind of got lost at was with like the middle curve at the top that goes upwards. I just kind of like didn't really understand how we got that part.
So it can't possibly, so it can't do this because there's no X-intercepts. Right?
Yeah. Okay.
So it really was, and it's got to slam up against that wall and slam up against that wall. So it really is a situation where it's going to be either parabola up or parabola down. And since the y-intercept was there, it had to be parabola. Now, the thing that is not necessarily true is that this might not be the minimum. Do you see what I'm saying? But the shape of it is really constrained because of the walls.
Okay, got it. But you're saying like it could technically be possible that it would somehow go further down for a bit and then go back up?
Oh yeah, definitely. In fact, let me see what the real, let me show you this again. I mean, this is not that big of a switch, but can you see how the minimum looks to be off the side here a little bit?
Yeah.
If I do real quick, if I calculate the minimum, left side, right side, yes. Yeah, my minimum is actually at 0.17, so it's over from 0. So this actually goes down a little bit and then back up. Yeah. So
Okay.
depending on the function, it could actually do that really a very big amount on one side or the other. But it will have to do this eventually to slam it up against the walls. Yeah. So when you do it by hand, I don't want perfect minimums. I don't want any of that. You will have imperfections like that, which is beautiful, because there should be no way for us to know that unless we just get it out of the calculator.
Okay.
Oh, I
Got it. All right, that's it. Thank you.
Sure. Let's see. How's everybody else? Are you guys out there? Dalton, Vanessa, Luke, Zach? If I don't, I'm going to head out. All right. I
We're
guess
good.
you got it.
Thanks,
Oh,
class.
sure.
Bye.
All right. Bye, everybody else.